Been looking at calculating statistics for data, right? So we collect data and we've been calculating statistics for. We've done what? Mean, median, mode, range, standard deviation, variance, IQR, the percentiles, quartiles, z-scores. And we've only looked at one summarization so far, and that was the box plot. We're going to spend the next few days looking at different ways of summarizing the data, presenting the data. We start with qualitative data, because the type of data you have is going to depend on how you present it. It's going to determine how you present it. One of the most common ways of presenting qualitative data is through a frequency table. So for a frequency table, you need the categories. They're just pretty obvious that it's qualitative. And the frequency, the count. And how many times does that specific point occur? By the way, frequency tables can also be used to summarize quantitative data, but that's done a little bit different. Frequency distribution lists each category of data and the number of occurrences of each category. Often, we're interested in what percentage is a certain category. This is the relative frequency, and it's fairly simple to calculate. Frequency divided by total. Now, if you want to convert it into a percent, you just multiply by 100%. And of course, we can also create what's known as a relative frequency distribution. And oftentimes, you'll see both frequency and relative frequency in the same table. So in terms of graphs, there are two commonly used graphs for qualitative data. The bar graph with a bar chart and a pie chart. For a bar graph, it's quite clearly what it sounds like. You have your horizontal axis, which lists the categories. You have your vertical axis, which lists the frequency. For each category, you just draw a rectangular box that goes up to the frequency. There are several methods for drawing those bars. The most common one for qualitative is you just center that category tick that's on the horizontal axis around the bar, right? So you just draw your bar where that tick is the center. For a pie chart, you start with a circle. What you want to do is you want to divide the area of that circle up based on the relative frequency of each category. So if you think of it as a pie, I like pizza better, so I'll go with pizza, which is actually, if you go to Italy, authentic is a tomato pie, which is good. So if you think of it as a pizza, the larger the relative frequency, right? So the large percentage of data in that category, the larger the slice. And you have to be careful. While it doesn't have to be perfect when you're hand drawing it, right? So if let's say category A is 51%, you don't have to draw exactly 51% of the circle. But it should definitely be larger than half, which is easy to see. Right? You shouldn't have a lower relative frequency category look larger than a larger relative frequency. Right? If you have a 25% and a 50%, your 50% should look twice the size of the 25%. 24 students randomly selected asked for their favorite study spot, their go-to study spot. For convenience, L is going to represent the library, D will represent the dorm, C will represent the cafe, and O will represent outside. Actually, can I make that an accented E? Find simple answers. So there is our data. We're going to create frequency and relative frequency. And we're going to do it in one table. Let's create a column for study spot. And then we just list the categories. We have 4 of them. Library, dorm, cafe, outside. And again, for convenience, I'm just going to use the first letter. frequency for each category. This is where it gets tedious, especially if it's a large collection. 24 isn't too terrible. But we'll be looking at that earthquake data set again. That is almost 2,500 data points. You have to actually count how many each data point occurs. So we have to count, for instance, for the library, how many times did library occur? 6, 7, 8, 9. Now the dorm. Seven. Cafe. And I can cheat. Sum those up and subtract from 24. That's going to be the outside, but that requires too much mental arithmetic. I counted 3. And then just check. Add those up and make sure you do get 24. 9, 7, 16, 21, 24. Okay. Now for the relative frequency. Now I can do it. It's the frequency of that category divided by the total number of data points. Now, you generally will not write it as a fraction. I'm just writing it there to show you how I'm getting it. So I'm going to move that. We're going to want to represent it as a decimal. And I am going to stick with my general rule of 4 decimal places for your relatives. Whenever I'm dealing with percentages, I always use 4 decimal places. Right? Yeah, it's the CX. Oh, perfect. 0.375. However, I'm going to be a stickler here. I'm going to say the test instructions does tell you 4 decimal places. Is that 4 decimal places? Yeah, it is. Seven out of 24. The dorm. .2916 repeating. So I'll say 0.2197. The cafe were 5 out of 24. 2083 repeating. That was 291, not 219. I'll fix that. And then 2083 repeating, so just 2083. And then finally, we're outside 3 out of 24. .125. And again, just check. What should the relative frequency sum up to? 1. Just make sure that they do. Now again, because of rounding, you might be a little off from 1. You could have like 0.9999 or 1.0001. As long as it's close to 1, that means you're good. It's just because of rounding. I know the fractions are going to add up. And they did actually sum up perfectly to 1. So that'll be our table. "40 students randomly selected, asked about their club membership. Want to determine the percentage of each category and determine the mode." Oh, the mode's easy. Let's just start with that. What's the mode? STEM. Now percentage of each category. Just find the relative frequency, multiply by 100%. That's perfectly 45. Nice. So 45% is STEM. Arts. Oops. $17.5. service, 10 out of 40 times 100%. We need to calculate for this one. It's 25%. And then athletics. 5 out of 40. Twelve and a half. Now, will that add up to 100%? So does that add up to 100%? Yeah. Does it have to? Well, I'm saying if you have the exacts, not a little off because of rounding. So again, and that's a different way. If you sum up, so let's say you collect this data, you sum up all the frequencies, well, that have to be 40.
Yeah.
Depends. Are you limited to just being in one club? What if I was in athletics and a STEM club? Now I'm being counted twice. Frequency will not add up to 40. Which means that won't necessarily add up to 100%. So it depends on how the question is being asked. If it's asking you to list all of your clubs, you may actually wind up with your frequency adding up to greater than what you actually calculate, for greater than the number that you actually asked. Right, it then is going to boil down to how do you want to represent your relative frequency? Right, because if you actually go back and look at the formula, it says sum of all frequencies. So your sum of all frequencies would be larger than 40, meaning your relative frequencies will still add up to 1. But that can be misleading because you only asked 40 students. Right? In which case, by saying in this case, let's say 45%, let's just say we're going to draw a conclusion from this and say that 45% of the student body is in STEM. If you just did the relative frequency based on the sum of all frequencies, that's misleading. That's actually probably going to be lower than the true percentage you would expect. You'd want it out of the 40, out of the original 40. Thirty students randomly selected asked for their t-shirt size. Create a relative frequency table. Here we just want the relative frequency. Now, I'm going to ask, whoops.
Is there a problem with this? Yeah.
Yeah, there is. Do you know what that issue is?
I don't want to like sound stupid, but it's like people can have like different sizes for t-shirts. Like maybe some brand is like one.
That's actually a good observation. Yes, different brands size differently. Also, let's just assume that all the brands actually have the same sizes. By some miracle, they all match up perfectly.
Some people could like buy on their side.
That's also true, yes. And let's now just assume that everyone's honest. What a world that would be. This somewhat requires some niche knowledge. Compare a men's medium to a woman's medium. They're two different sizes. Men's medium is larger. Woman's medium would probably be closer to a men's small. Not quite. I think it's slightly larger than a men's small. All right, so out of those 12 mediums, are all those 12 mediums actually the same size? So again, you have the branding issue. I've had brands where I've bought a freaking XXL and it's a large. Okay, this is definitely not right. I've had some where it's like I buy an XX and it feels like a 5X. Put it on, it's like, oh, okay. We're just going to ignore that. For this course, we're going to assume that all things equal, which actually is a principle in statistics. I think we actually do learn it. All things equal principle. Yeah, not. Okay. I guess I could do it this way instead. You may see a frequency table written this way too, by the way. Oh, that's not supposed to be frequency, that was supposed to be relative. First, let's make sure that the sum of the frequencies is 30. 9, 21, 29, 30. Okay. just want relative, not percent, so these will be staying as decimals. So 2 out of 30. .0 and then 6 repeating. That is 0.2, 3 repeating. Medium. Exactly 0.4. Large, 0.26 repeating. Extra large, 0.03 repeating. There's your relative frequency. So we're going to go back and touch on what you said about the lying. That in general is always an issue with collecting data when you're doing a survey. People tend to lie. They tend to say what they think you want to hear. Which is why if you want to collect a survey, you don't really want to do it in person. You want to let them respond anonymously. Because they're way more likely to be honest in that case. Unless they're just an absolute troll. I generally look into who's performing the survey, and I know what they want their results to be, so I'll purposely skew it. "30 people randomly selected, asked for their favorite season. 9 replied. So it was 9 spring, 9 summer, 8 fall, and 4 winter. I'm going to hand draw a pie chart and bar chart. Bar would probably be easier. What you want to do is actually just move this to a different slide. Do it this way. And I go with autumn because of the autumnal equinox.
What is that?
So you have, the seasons are basically determined by length of days. So you have two equinoxes, the spring and the autumnal. And those are the 2 days with the amount of daylight and amount of nighttime on the equator is equal. And so it's exactly 12 hours a day, 12 hours a night. Then you have, I think it's the vernals, summer and winter. Summer is more day than night, and winter is more night than day. And that's around how, and that's generally how they choose the first days of the seasons. That's how they chose it. Based on the it's not vernal, it's firm sun, but based on the equinoxes and the equinoxes. Which you go up north to North Pole, you have periods of 24 hours a night and 24 hours a day because of the tilt of the Earth. I think if you're at exactly the North Pole, half the year is night, half the year is day.
The year?
Mm-hmm. Because of the tilt.
How much?
Right at the very top.
Uh-huh.
That's not spinning as it rotates because you're spinning along that point that's on the axis of rotation. So the night and day cycles determine exactly based on where you are, where Earth is in its revolution. Because that will never pull away from the sun if it's facing the sun, right? So it's over here.
Yeah.
It's always going to face the sun. Over here, it's always going to come away from the sun. Because it's right on the axis of rotation. Which, by the way, the axis of rotation actually wobbles. So there'll be some point in the, relatively speaking, not too distant future where we're going to be back at a straight vertical axis of rotation. In which case, I believe we lose all seasons.
Is that like daylight savings, or is that some...
Oh, daylight savings is just a human invention to piss everyone off. Spring was 9. So there's my bar for spring. Summer was also 9. There's my bar for summer. 8 for autumn. And winter gets no love. Even though it is objectively the best season. It's not an opinion, it's just a fact. What's that for? Something else to get used to. North Pole and South Pole, opposite seasons.
And that has to do with
When it's winter here, in Australia it's summer. So in Australia, Christmas occurs in the middle of summer.
I don't know.
So the whole notion of a white Christmas is a northern hemisphere thing. Australia, if they had a white Christmas, or actually if they had snow in general, I think they'd probably freak out. Their entire economy would probably crash if they saw snow. Now for the pie. This I can just do like this. I don't need it to be bigger. We want this in terms of relative. This is going to be what, 9 out of 30? 0.3, so 30%. 30% of this should be for fall, 30%, not fall, sorry. 30% for spring, 30% for summer. Of course. 26.67% for fall, and then 13.33% for winter. Winter should be the smallest. Right now, again, I don't have to be perfect, but I said what, 30% for spring and summer. 30% is larger than a quarter. So I don't want to say that that's 30%, because that's clearly not. So I'm going to do something like this, I think. Just going to draw, that would be a quarter. No. Kind of looks like 30%. Oh, and by the way, spring has to be the exact same. That's not the same. As long as it's close. Okay, I think that's good enough for my work. That leaves 40% of the area left. Fall was 20, let's just round it to 27%, which is more than half of what remains. That would be half, right? No, it's slightly more than half, because that would be 20%, so maybe like that. And that would be your pie chart. Again, is necessarily each one perfect percentage of the area? I can promise you not. But hand drawn, that's a pretty good representation. And are you ever going to actually hand draw? Probably not, except for a test. And by test, I mean exam. Teaching knows that course, and I know for their test on this, I actually required them on the test to use Excel and generate the plots that way. I didn't want them to hand draw. I might do the same thing here. Notice with the bar chart, I don't have the bars touching. You do not want your bars to touch in a bar chart. If they do touch, that's a different type of chart. It's called histogram. All right, so sometimes when you're given, you have a lot of categories. it may be simpler to try and combine some categories. Which is what they want us to do here. Any category with a frequency less than 3, they want to put into an other. Right, so really we're just looking at the main ones. And that also happens a lot. Right, if you look at, I know they've done search this, what brand car do you own? They don't literally list every single brand. They do usually the main ones. You have Ford, Chevrolet, what are the other ones? Dodge, Toyota, and then you'll see like an others category. Next, we're going to do major. Stick with the count. Comp sci, CS, bio, business, BS. Business, the maths, and then other. Now for the other, how many do you have?
3.
That's simple enough. Wait, you want a secure career? I'm sorry. Specifically cybersecurity. You'll always have a job. Pie charts shown. Use it to determine the most preferred study spot and the least. And then, so, okay. So it's not given on here, but it is given in my example. I probably just missed it. I'll worry about that later. I'll put the percentages down later. First, let's just assume, because a lot of pie charts will be like this and not give you the percentage. Just looking at that pie chart. What is the most preferred? The library, right? Why the library?
It's the biggest piece.
Yeah. Simple answer, right? It's the biggest piece. Biggest piece of the pie. Least preferred. And why? Smallest piece, right? So you'd be really happy if you got that library slice of pizza. Unless you don't like pizza. Now I'm going to include the percentages. That's just going to help me do the bar graph better. Right, and there are pie charts out there that will give you the percentages. start outside and go counterclockwise. I could probably just start here and go counterclockwise and say dorm library cafe outside. Actually, I like that better. Now I don't have counts. So I'm going to take this to be relative frequency instead. I'm going to take each tick to be 20%. Dorm is 29%. Oh, don't automatically draw a line. No, that's too high. That'd be about there. That's good enough. And so we'll say that's the dorm. Library was 38. That'll see that the same with. Okay, that's fine. What was cafe? 21? That's 20, so maybe we're right about. And then pour outside, 12%. And that's good enough. Just leave these. Survey jobs conducted. Found 37 students had an on-campus job, which corresponded to a relative frequency of 0.37. How many students were surveyed? How'd you get it?
I didn't get that. Could you try again?
37 divided by 100 is 0.37.
Software X. So it would be 37 divided by 0.37, which is the next one. That was pretty easy. But that is how, in general, how you would go about it. So frequency, relative frequency, bar graph, pie chart for the source location. So again, I'll just import data. And I'm not going to worry about that second part. I think it said to repeat it for type. Yeah, I'm gonna do it. Source location, which is, I think, the place. No, location source right there. Okay. Hide. Frequency. Insert. Pivot table. Range. What do I want? I'll just drag it all the way down. Probably just do this. 2, 4, 29. Okay. Range, there we go. Where do I want it? Existing worksheet. Location. I don't know. Here. Okay. What's this? Turn on pivot table. Field list. Oh, I have to pick one. Uh, no, I just want that. Now, where's the count? Custom count. Sums. What are you doing? That. Okay, so this doesn't work the way it should be. I'll figure that out later. So I want bar graph pie chart. Insert. Where are you? Bar right here. And then just pick. I like 2D column. Yes, it should be. Sync data. Oh, I have a pivot in here, it's not going to let me do it. Are you kidding me? Delete. Select data. Thank you. Yeah, I'm actually going to need the counts as well, so I'm going to need to create that. Oh boy. I'm going to figure out what's going on and I'll just create a separate video and upload it. 'Cause I don't know why it's not doing what I want it to do. So for now, And so don't forget you have those 2 assignments that are coming up. Like I said, I'll figure out what's going on with this pivot table. I'm probably just being an idiot. That's not simple. And I'll either show it next class or just upload it or something. Are there any questions? So for the rest of the class, either discuss the group assignment or this worksheet. So go ahead and get into your groups.
Really? Yeah.